Cool. All right, so we are recording. So some quick announcements. So I already finished grading all of the tests. So if you email me the picture of the box plot, I already took that into account. So or anything. So anything you email me, I took that into account when accounting for the grade that you have right now on Canvas. So all of the exam have been graded. So for the exam were pretty all overall like average. The average grade was a C. So there's some student who got above a C, some student who got below a C, but essentially the average for this first exam was a C. So you kind of want to make some quick announcement in regard to the test. So let me kind of move over to the test. And you should be able to now see the test. I unlocked it since everybody should have already taken the quiz or taken the exam. So it should be unlocked. No, Siri. All right. So some quick thing, because for this test I did something that I'm not gonna do for the following exam or any other quizzes. So some of you need to kind of follow instruction. Because the thing is, the way I put the answer onto Canvas, it will only accept it in a certain way, especially when we're dealing with percentage. If you look right here, I said final answers should be in decimal and use 4 decimal places. Most of you didn't follow those instructions. Instead of putting like 95%, or sorry, instead of putting 0.95, you put 95%, which Canvas marked it wrong because I didn't tell Canvas that was the correct answer. I only told Canvas the correct answer is 0.95. So anytime I said final answer should be in decimal, is saying pretty much I don't want percentage. I want it to be in decimal form, and do follow the instruction on how many decimal places I want. Because for this test, I actually went back and I saw all of them. So if you put 95% or 0.95, I actually gave you credit. Yeah, but if you remember, we said percent. Percent is a decimal value, or we could write it as a percent. So if I say final answer is in decimal, from now on, you should know that represents that you want to give it to me in a decimal form. I'm not going to want percentage form. Because for this one, I went back and graded all of those questions. Well, you just write it as 0.9500 or 0.9375. Yeah, that's fine. If they disappear, they disappear because pretty much Canvas will know that the zero is essentially floating zero. So it doesn't matter if you're keeping it down. All right, so that's one of the announcements. So from now on, if it says final answer should be in decimal, there shouldn't be any more like confusion. This mean I want it to be in decimal form, not in percent. If I say I want it in percent, I'll let you know I want it in percent. But for the most case, I'm not gonna want it in percent. I'm gonna want it as a decimal. Which is 21. All right. So also there was a typo on the answer for one of these. Cool. All right. So for this question right here, and for that one, it's question number 22. So I'll put it in the chat. So in the chat, so let's put number 22. So for problem number 2, the actual answer is 0.9375. because I accidentally put the answer to be 0.9, well, sorry, 0.8889, which is, so if you are doing test correction or anything like that, you do want to come up with this answer because this is the correct answer, 0.8889. That's a miscalculation because on Canvas, it will say that's the correct answer, but I'm letting you know right now that 0.9375, that's the correct answer for number 22. So for number 22, it should be 0.9375. All right. Any question in regard to that? Cool. All right, and then somebody want me to go over 21? Cool. All right, so if you look at 21, I'm not gonna go in detail like I usually go over because all right. Also, if you put 0.9375, I manually went in there. So Canvas is gonna mark it wrong. But what you have to do is look at how many points was awarded to you. So don't look at that it gave you a wrong or it said that was wrong. Look at how many points was awarded to you. If you got the full amount of points, that means you got it correct, and that's the reason why you got a full amount of points. So if you put 93.75 or if you put 0.9375, I gave you full credit. I think I gave you like 5 points or something like that. All right. So let me go over 21 real quickly. So if you look at 21, the first thing you kind of have to know, for 21, you wanted to use a Chebyshev rule. So for 21, you wanted to do the Chebyshev rule. So for the Chebyshev rule, you look at your K. In this case, what was my K? Yeah, K is 2. So if you use the formula for Chebyshev rule, you're going to do 1 minus 1 divided by 2 square, and then figure that out. So that's how you got to do 21. It wasn't that hard. If you go back to the section for chapter 3, pretty much I went over it in more detail. For this one, I'm not going to go over it in detail because that's something you should have already know. But if you do need me to go over in detail, you could go to my office hour. All right, so that's 21. So let's see 37. So this is 39, 38. All right, so for this one, all I'm asking you is what the population of interest. So for this one, who are they focusing on? Yeah, the answer is Americans. That's it. You don't have to put 100 because I'm not asking you for the sample size. Because pretty much they're just focusing on American. Because that's who they're sampling. Because if you remember, whenever I tell you population, you're focusing on like who do they focus on. So since they're just focusing on American, your population of interest is just Americans. And that's it for that one. All right. So you do kind of want to, yeah, that's incorrect. You're giving me the sample. I want the population. Yeah, because by you telling me 100 random American, that just you giving me the sample. It's not giving me the population of interest. All right. So that was a test. So you do want to kind of go over your test and see what they did wrong. If you need help on any of the questions, you do want to show it for my office hour. So that way you can ask question about it. All right. So that's it for that test. So everybody should be able to see their test and see what they got right, what they got wrong, so on and so forth. All right. So Ari input a link for that way you could do the test correction. So since I open up the test today, that means I'm gonna want the test correction by the latest. It's gonna be next week or next Wednesday, and it should be July the 8th. So you're gonna have all the way to July the 8th to be able to do your test correction. So if you look at week number 4, because it's gonna be due week number 4, you're gonna see something called test correction or test 1 correction. So right here, what I want you to do, I just want you to upload the test correction onto here. Let's get the chat out. So if you look right here, you said test 1 correction will be due July 8th. So for the test correction, you could do test correction for as many questions as you want. You just make sure that you just input, that you keep the same rubric or the same format that I have for the test correction form. And for the test correction, if it said to use your calculator, you put the step that you use in order to find the answer in your calculator. If I ask you to, like, say, for the problem that I want you to do the Chebyshev rule, I want you to give me the full answer like I did it in class. So I want you to show me, like, how do you find the K value? You doing 1 minus 1 divided by K squared. And for your final answer, it should say at least whatever percentage that it should be. In the test, I was more relaxed about not letting you, or that you didn't have to say at least or approximately. But I'm letting you know for the test correction, I am going to be looking for that, because for the test correction, I want it exactly the way I did it in class. Because I know for the test, since it's essentially online, it's harder for you to be able to do that. But since you're going to be actually writing down the correction, I want them exactly the way that I did it in class. So if it doesn't say to use your calculator, you should be showing me by hand how you got those calculations. If it says to use a calculator, you tell me which function you use in the calculator, and then you tell me the result that you got in the calculator. All right. And let me upload a test correction form there, because I think I forgot to upload test correction form. So I'll upload it in week number 4. All right, so I attached the test correction form right here. So you do not have to print this out, but I do want you to keep the same format. So like right here, where it says total points the question was worth, you tell me how many points the question was worth. If it was worth 5 points, tell me it was worth 5 points. If it was worth 0 points, so that would make sense. If it was worth 2 points, tell me it was worth 2 points. And then right here, tell me point received for the question / part. So you tell me how many points you got for that question. So if it was out of 4, but I gave you 2 points, you put 4 right here, and then right here you put 2. And then right here where it says point awarded for correction, right here, it should be blank. I'm actually gonna fill this out for you. So leave this blank. Right here where it says question number, you put the question number. So you put number 35, number 30, so on and so forth. So for this one, for parts, you would put nothing because there's no parts to these questions. So for parts, so pretty much for this last line should be left blank. And also for version, leave this blank because there's no different version. All right. So that's it. So for the test correction form, you tell me how many points was the question worth, tell me how many points did you get, and you tell me which question number are you doing a correction for. And then right here, you have to make the correction. And then you have to tell me, like, explaining how you got your correct answer. So that's the test correction form. Any question in regard to the test correction form? All right. And also just remember, for the test correction form, you could do as many test correction as you want. So you could do as many test correction as you want. So if you miss like 5 problems, you could do test correction for all 5 problems. The only thing I do ask of you, when you're submitting this onto Canvas on the test correction for test 1, I want it as a singular PDF file because I don't want like 20 different images that I have to upload and check. I just want it as one PDF file. So that's where the Cam scanner or the Adobe scanner is going to come handy, because when you use Adobe scanner or Cam scanner, that will pretty much, it will take all the picture and it will make it as a singular file. Yeah, that's the whole point of a test correction. If you correct the question that you got wrong, you could get half a point what you missed. So if you missed 4 points, you could get back 2 points. So can we print them, then take a picture of our work and upload as a PDF? Yeah, that's fine. As long as you submit it as a PDF file, that should work fine. All right, so just remember, when you upload the test correction, I want it as a singular file, not 20 different files. All right, once again, there is no limit to how many test correction you could do. So you could do test correction for all the problem, doesn't really matter to me. So there's no limit, but there is a limit on how many files I want you to upload. There should only be one file uploaded. If you got a vocab question wrong, then what you want to do, you want to look up that vocabulary word and see why you got it wrong. So for that one, like, the correction is mostly going to be just the explanation about why you got it wrong. So you do kind of want to look at the vocab and just see, like, okay, why was this answer supposed to be something different than what you gave me? All right. Yeah, so if you got point that value on a problem, then whatever the problem was worth, you could get the remaining, well, you could get half of the remaining points. Or if you're asking that you miss 0.62 of a problem, then essentially you could get that half back. So however much point you miss, that's how much point you could get back, half of it. All right. And the reason why it said the Chegg.com, this is a test, because I emailed them saying that how can people solving question on Chegg know that this is a test? So it's kind of like a watermark. So if you were to just like take a screenshot of the question, put it up into Chegg, I can easily be able to, well, the people solving it could easily see that it's a test question. And I could easily Google search it, because if I Google search Chegg.com, this is the test, it will be the first thing that pop up. So that's why I have that. Essentially, just a watermark to it. All right. Any other question? All right, quick. All right. So once again, to kind of recap. So for the test correction form, no. So all you have to do, you go test one correction and just upload it here. And then once everybody upload it, I'll be able to grade it and I'll give you half of the point that you get correct. All right. Also, just know for the test correction, there's no partial right answer. The way I'm going to look at it is either going to be correct or it's going to be incorrect. I'm not going to give any partial credit for it. So if you did everything correct, but you messed up on one little thing, oh well, you should have had checked that part before you turned it in. So just know for the test correction, I am going to grade them extremely harsh. So if you're missing anything on it, like I'm just going to cross it out and say you get 0 points. So an example, say if you're solving the problem for the empirical rule and you put 95%, but you forget to put the approximately 95%, you're not going to get credit for that. You only get credit if it's completely right the way that we did it in class. So do take your time with it. If you do have any question, pop up into office hour, or if you want to make an appointment to have a one-on-one session where you could go over a problem with me, do it. But like once you turn it in, if anything is partially wrong or off, you are going to lose the entire points for that. All right. So that's it for the announcement. Any other questions before we go ahead and move on to chapter 5? All right. So let's go into chapter 5. All right. So if you remember for chapter 5, we left off when we were doing mutually exclusive. So we kind of went over like what is a mutually exclusive event. So what we're going to go over today we're going to go over example of events that are not mutually exclusive. So that way you can kind of see the counterpart. Because I already showed you a bunch of examples for mutually exclusive. Now I'm going to give you some example of events that are not mutually exclusive. So let's go over the first one. So if you look at S, it says the sample space is 0, 1, all the way through 9. So this one says event A is 0, 3, 5, 7, 9. So that's event A. Then you have event B. Event B is 1, 2, 5, 6, 8. But if you look at these two events, they're not mutually exclusive because they do share some information. Which number do they share? 5. Perfect. So that's why these two events are not mutually exclusive, because since they share something in common, since both of them have a number in common, that's why it's not mutually exclusive. All right. So that's the first example of something that's not mutually exclusive. Here's the second example. So for event A, it says a car is a Honda. Event B, it says a car is black. So let's kind of do a Venn diagram on this one. So we have a black car. And then we have a Honda. But if you look at those, are those two even mutually exclusive? Is it impossible to get a black Honda? So you're telling me it's impossible to get a black Honda? Like, no, the answer should be yes, it is possible to get a black Honda because there are black Hondas out there. So for this one, you do have an overlap. So since you have an overlap, that means it's not mutually exclusive. All right. So this next example, I got it from a student. because he actually told me this was mutually exclusive. So event A says a person gets struck by lightning. Event B, a person get a A in a statistic class. All right. So are these two events mutually exclusive? Like if you get an A in a statistic course, does that mean you're immune from getting struck by lightning? No. So since these two events have some overlap, for this one, it will be considered not mutually exclusive. So you kind of know the difference between mutually exclusive and non-mutually exclusive because it is very important that you kind of understand that idea. All right, but that's it for that. Those examples. Any question for those examples? All right, so let's go over to this addition rule. So we're going to do the addition rule. So the addition rule is when we're adding up probability. Correct. The last two are not mutually exclusive. So if you remember from yesterday we went over that this symbol, if I remember correctly, is the AND statement. So today we're going to do the addition rule, and the addition rule is when we're doing the OR statement. So anytime you see a union or a U, that means OR. So for a union, if you remember for the AND statement means that both of those events have to concurrently happen at the same time or at the same object. When we're doing an OR statement is saying either one thing can happen or the other thing could happen, but both of them doesn't have to occur at the same time. So whenever we're using the addition rule, it's a little bit more relaxed because an AND statement means both of those outcome or both of those events has to occur at the same time. But when we're doing an OR statement, you're saying either this could happen or this other thing could happen, but both of them don't have to occur at the same time. So we're first going to go over the addition rule when we have mutually exclusive event. So when we have mutually exclusive event, if we're doing a Venn diagram, we have event A and then we have event B. So if I want to find the probability of either A or B occurring, all you have to do is add those individual probability up. So if I want to find the probability of A or B occurring, all we have to do is just add up the probability of A and add it up to probability of B. So for the addition rule, it's not limited to just 2 events. We can actually do multiple events. So depending on how many mutually exclusive events do we have, you can actually do multiple. So if we have 3 events and all 3 of them are mutually exclusive, if I want to find the probability of A or B or C, all I have to do is get the probability of A, add it to the probability of B, and then add that to the probability of C. So that's your addition rule when you have mutually exclusive or disjoint event. All right. Everybody good in regard to that so far? Cool. Crowd go wild. All right, so let's do our very first example. So for this one, says raffle tickets are sold for a raffle. Makes sense. You buy 2 tickets and your friend buys 3 tickets. One ticket is randomly chosen as the winning ticket. What are the probability you or your friend win this raffle or wins the raffle? All right. So for this one, why is the event you win the raffle or your friend win the raffle? Why are those 2 disjoint events? Cool, perfect. So you can't both win. So either you're gonna win, your friend's gonna win, or anybody else who bought the raffle tickets are gonna win. Because for this one, there's only one winning ticket. So that's why they're mutually exclusive. Because either you're gonna win the raffle or your friend's gonna win the raffle. But since there's only one winning ticket, it's impossible for both of you to win the raffle. All right. So for this one, what we want to do, if you look at the last sentence, well, the last sentence in that first one, it says, what are the probability that you or your friend win the raffle? So if you look at it, we have A or B. So we want to find the probability of A or B occurring. So for that one, we're going to get the probability of A. We're going to add it to the probability of B. All right. So if you look at the probability of A, the probability of A is you win the raffle. So how many people, oh, it's not how many people, how many tickets did you buy? 2. How many total tickets were sold? Yeah, 50. Cool. So the probability that you win the raffle is 2 out of 50 because you bought 2 tickets and there's only 50 tickets out there. All right, let's go to your friend. So how many tickets did your friend buy? 3. Out of how many? 50. Perfect.
You just said it's not saying. Where's the name? Not like that. Nah, hit the pole.
All right. So if you look at it, we get 2 over 50 plus 3 over 50. If you know fraction, 2 over 50 plus 3 over 50 is 5 over 50, which is 1 over 10, which is 0.10 or 0.1. And that will be your final answer. So there's a 10% chance that either you or your friend will win this raffle. And we're done. Any question in regard to this first example? Excellent. All right, so let's go ahead and do this problem for Shark Tank. So for this one says Shark Tank is one of my favorite shows to watch. The probability model to the bottom shows the distribution of pitches by the industry for the show Shark Tank. So if you look on the left-hand side, it has the industry. If you look at the right-hand side, it's the probability. So you're saying how many of these pitches were for the first one, it said food and beverage. So it says 20% of the pitches that are on Shark Tank are for food and beverages. If you look at the next one, it says lifestyle/home. 16% are from lifestyle/home. And then if you look at children/education, is 10%, so on and so forth. So we're going to assume that all of these are mutually exclusive from each other. So we're going to think that each one of these industry are mutually exclusive from the other. So in the food and beverage business or industry, you're not going to be in the media business or media industry. So let's do part A. So for part A, it says verify that this is a probability model. So how can I verify that this is a probability model? Like, what are the conditions that I have to check, or what are the rules that I have to check? Cool. All right, so somebody says it should sum up to 1. So if I get the probability of all the events, it should add up to 1. What's the other condition? Cool. So the probability of the events should be between 0 and 1. All right, so I'm gonna go ahead and check that. So if you look at all of the probability, if you look at them, they're between 0 and 1. So we have 0.20, 0.16, 0.10, 0.10, 0.19, 0.05, 0.07, 0.03, 0.04, 0.06. If you look at it, you don't have any value higher than 1. You don't have any value lower than 0. So this first one checks out. So the next one, or the first one that I skip, is this one. So what I have to do, I have to add up all the probability and I have to see, do they add up to 1? So we have to do 0.20 plus 0.16 plus 0.10. All right, so if I add up all of those numbers, what do those numbers add up to? Yeah, 1. So this checks off. So we'll say this is a probability model. All right, so that's a little review on what we went over yesterday. Everybody go with part A. All right, so let's do part B. So for part B, it says, what is the probability a randomly selected pitch is either for pets or media? So for pets, I'm going to use P for this, or actually, I just put pets. And then if you look at it, it says or in this case is the key word. So you put union, and then you put media. So we want to find the probability they're in pets or in the media industry. So what percentage are in the pet industry? Good. They get point. They get 0.05. How many of them are in the media business? 0.03. So you get 0.08 or 8%. All right, so our final answer is 0.08, or if you want to write out the percent, 8%. So this is telling you there's an 8% chance that in a pitch, it's either going to be for the industry of pets or media. Okay, it could be one or the other. It doesn't have to be both of them at the same time. But that's it for B. Any question for B? All right, so to see, it says, what is the probability a randomly selected pitch is either for food and beverage, or fashion / beauty, or health? So for this one, we want, yeah, we'll put food or beauty or health. So if you notice for this one, we're not limiting it to just 2 events, where we're doing this for 3 events. So what we have to do, we have to get the probability of each individual event and you have to add the 3 up. So what's the probability they're in the food / beverage business? Good. They put 0.20. How many are in the beauty business or fashion / beauty? Yeah, there you go, 0.19. And how many of them are in the health? All right, so if I do 0.20 plus 0.19 plus 0.04, you're gonna get 0.43. And we're done. All right. So this is the general addition rule if the events are mutually exclusive. So if each event are mutually exclusive, all you have to do is just get each individual probability and just add them all up. And that's your probability for your general vote for the OR statement. Any question in regard to the general addition rule for mutually exclusive? Alrighty. So now we're gonna do the general addition rule. Yeah, for this one, you just, well, let's kind of look at both of these. Well, let's look at the raffle. For the raffle, did they give me the percentage? No, if you look at it in the raffle, they don't give me the percentage. So that's why what we had to do in the raffle, we had to first find the percentage, and that's why we're doing 2 divided by 50. If the 2 with the actual percentage and the 3 with the actual percentage, you would do 2 plus 3 and you get the percentage. But in this case, since they don't actually give us the percentage, we actually have to go ahead and find it. And that's why we have to do 2 divided by 50 because they don't give us that percentage or that probability. But if you look at the one about the pitches for Shark Tank, do they give us a probability in this one? Yes, so they do give us a probability. So in this case, all you have to do is just add the probability. So you do kind of want to notice like when do we divide, when do we just add them? You divide it if the probability is not given to you. So kind of if you remember from I think yesterday when we did it about the M&M and like how many color M&M do we have, you get the color M&M that you want and you divide it by the total amount. The same thing for the raffle. Since the probability when they give it to you, you first have to find it and then you add it. But for the one about Shark Tank, since they already gave us a probability, there's no need to divide it. You just add them all up, and that's it. All right. Any other question? All right, good. All right. So we're gonna do the general addition rule again. So this is still a or statement. The only thing different, instead of it being mutually exclusive, it's not gonna be mutually exclusive. So if you look at it, if you look at the Venn diagram I drew here, oops, sorry about that. We're gonna have some information that they share. So this is for when they're not mutually exclusive. So let's go ahead and see the formula. So for the formula, I gave you 2 formulas. They're both the same formula. The only thing is one of them says or, the other has the union and the and statement. So it kind of depends on you. So if you look at this formula right here, it says the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. If you look at this formula, it's exactly the same thing. The only thing different, instead of writing out or, I put U. Instead of me writing out and, I put the intersect. So the same formula, you kind of depend on you. If you like seeing the actual word there, just use the first formula. But if you're okay with the mathematical notation of U as or and intercept as and, just use the second formula. Everybody good so far on it? All right. So up next, what I'm going to go ahead and do, I'm going to show you where or how did the formula come about. So if you remember when we were doing before, we would get A or B. We would just add up the probability of A and add that to the probability of B. So let's see how that work out with this. So if I get the probability of A is all of this, correct? So that's the probability of A. But if I get the probability of B now, that'll be this. But if you kind of notice, when I got the probability of A and then I got the probability of B, I actually double counted this middle area. So since I double counted that middle area, that's why we actually subtract by the probability of that area that I double counted. Because the thing is, whenever we have 2 events that are not mutually exclusive, if you get the probability of A plus the probability of B, you're going to be counting people or object twice because that's what the middle portion is essentially people or objects that fall into both criteria. But in order to avoid that, you have to subtract by the overlap or by the intersection. So that's how the formula came about. So what you have to do, get the probability of A, add it to the probability of B, and then subtract it by the people who essentially fall into both camp. Everybody good with that? All right, everybody good with that. So we're gonna go ahead and do a very basic problem. So we're gonna go ahead and do this first example right here. So for this first example, it says use the information that for event A and B, we have probability of A is equal to 0.4, we have probability of B is equal to 0.3, and we have probability of A and B is equal to 0.1. So a good and easy way to kind of know that this event is not mutually exclusive is that they gave us the probability of both events occurring at the same time. Since we know both events could occur at the same time, that should kind of tell you that these two events are not mutually exclusive. Because if they are mutually exclusive, if I would have probability of A is equal to 0.40 and probability of B is equal to 0.3, if I have the probability of A and B, if these events are mutually exclusive, remember mutually exclusive means both of them cannot occur at the same time, this should equal to 0. So a big hint, if I give you the probability that both of the events are occurring at the same time, that's kind of letting you know that they're not mutually exclusive. All right. Everybody good so far with that? Great. All right, so if you look at the problem, it says find probability of A or B. So to get probability of A or B is equal to probability of A, add it to the probability of B, subtract it by the probability of A and B. So for this one, get probability of A, which probability of A is 0.40, plus the probability of B, which is 0.30, minus the probability of A and B, which A and B is 0.10 or 0.1. So if I do 0.40 plus 0.3 minus 0.1, what do we get? Cool, and we're done. And remember, 0.6 is not 6%. This is equal to 60%. Don't get confused with that. All right, any question? All right, so let's do the second example. So whenever we say, because if you kind of remember from yesterday, whenever we denote A and B represent the probability that both of those events occur at the same time. So kind of going back to the example that I gave about a Honda and it being black. So if I were to say probability of a Honda and black, what that will represent how many black Honda do we see out in the world. So if we want to find the probability that we have a Honda that's black, the N represents that we want only cars that are black Honda. We don't care about if it's a black Mustang or a black Kia or black Lamborghini. We only care if it's a black Honda. So whenever you have the and statement means both of those outcomes should occur at the same time. All right, so let's go ahead and do this next problem. All right, and one thing I do recommend, anytime you're doing problem like these, label the percentages first. Because you first want to label them, and then it makes it so much easier to substitute everything in. Because if you properly label everything, it will make the problem 100% easier to do versus if you try to substitute it straight into the formula, you're most likely going to do some mistakes. So whenever you're doing this, first label everything for that way you know what everything represents. Then what you want to go ahead and do is substitute it into the formula. All right, so let's look at this problem. It says about 20% of movie coming out of Hollywood are comedy. Warner Brothers has been the lead studio for about 9% of recent movie, and about 2% of recent movie are comedy from Warner Brothers. Let's see, denote the event a movie is comedy, and W denote the event a movie is produced by Warner Brothers. So for this one, we have two events. One of the event is C, which is the movie is a comedy. We have C, which it means it was produced by Warner Brothers. So those are my two events. So first thing we're gonna go ahead and do, we're gonna go ahead and look at each percentage and label what each percentage is. So first thing we have is 20%. Also important, you wanna be able to convert these into decimal or into percentage or leave them at percentage. I'll do it as a percentage, or as a decimal as a percent. So we have this 20%, I'm gonna write it as 0.20. What did that 20% represent? Does it represent a comedy movie? Does it represent a movie that was produced by Warner Brothers? What does it represent? All right, so for this one, if you look at the problem, is it about 20% of movie coming out of Hollywood are comedy? So it's telling me that this represents movies that are comedy. So we say the probability a movie is comedy is 0.20. Does that make sense? Because in the chat room, I kind of see a little bit of confusion. Does that make sense why probability of C is 0.20? Because they're talking about only comedy. All right, let's see if we get better luck on the next one. So what about the 9%? What does that 9% represent? Cool. So those are movies from Warner Brothers. Perfect. And also remember, 9%, you write it as 0.09. All right. So last year, we're going to do the 2%er. So we have 2%. So if you look at it, it said 2% of recent movies are comedies from Warner Brothers. So for this one, is it a comedy? Is it Warner Brothers, or is it both of them? Cool. So it's both of them. So since it is both of them, you go probability of comedy and Warner Brothers. And that's 0.02. Remember, 0.02 because that's 2%. All right. Everybody good for A? All right, everybody's good for A. So for part B, it says, what is the probability that a movie is either a comedy or produced by Warner Brothers? So right here, there's a key word, is or. Oops, I want to cross it out. I don't want to highlight it. Is or. This is telling me we're doing the general addition. So since we're doing the general addition, you have to kind of know we have two different formulas we could use. One for mutually exclusive, one for not mutually exclusive. So for these two events, a comedy and Warner Brothers, are they mutually exclusive to each other? Or is it possible we could get a movie that both of these events happen at the same time? Cool. So we'll say not mutually exclusive. So since it's not mutually exclusive, and kind of like if you would have been paying attention, since you have this, since this probability is not equal to 0, that's telling us that it's not mutually exclusive. Anytime it's mutually exclusive, the probability of both of the events occurring at the same time should always equal to 0. So for this one, we're going to say probability of C. And remember, since the OR, you say union W. There you get probability of C plus the probability of W plus the probability of C, well, my mistake, and W. Cool. So that's the formula we're going to use. So once I know this is not mutually exclusive, you use the second formula for the general addition rule. All right. Everybody good for that? All right. So if you have everything nice and labeled, this should be easy. But if you look at it, probability of C is 0.20, so you put 0.20. Probability of W is 0.09. And probability of C and W, oops. Remember, I messed up on the formula right now. That should be a minus. So if you did put a positive, change it to a minus. So we do minus 0.02. All right, so we're going to do 0.20 plus 0.09 minus 0.02. So if we subtract, well, if we do 0.20 plus 0.09, you get 0.29 minus 0.02, you get 0.27. And that's your final answer. So your final answer for this one should be 0.27. So the probability that we get a comedy or a movie produced by Warner Brothers is a 27% chance of that occurring. And that will be it for this first example. I'll tell you the second example, but the first one really didn't count. All right, any question for this example? All right, so this example is when we're given the percentage. So I think for the next example, so look at this next example and tell me, do they give me the percentage in this problem? All right, good, yeah. So if you look at this one, they don't give me the percentage. So in this one, that's when we're gonna have to divide. So kind of notice the difference. This one, they gave us these percentage. So that's why we can just add them and then subtract them. But in this one, since they don't really give us the percentage, they just tell us how many people are involved. In this one, we are gonna have to divide them. So for this, I'm gonna show you two ways how to do them. One of them is gonna be doing the Venn diagram. The other way is gonna be with just doing the formula. All right, so let's read this problem. So we're first gonna do it with the formula, then we'll do it without the formula. So for this one, it said in a school of 320 students, 85 students are in band, 200 students are in sports team, and 60 students participate in both activities. What is the probability that a student is involved in either band or sports? So for this one, what is one of my events? Cool, all right, so we got both of them. So one of our event is band. I'm gonna label this as B. Other event is sports team. And we'll say this is S. Cool. All right, so these are only the events that could occur. Either a student is in band or a student is in a sports team. Everybody good with that? Cool, everybody good with that. All right, so let's go ahead and do this. So I'm gonna find the probability somebody is in band. I'm gonna go ahead and find the probability somebody is in a sports team. And I wanna see how many people are in both a band and a sports team. Because if you look at this one, is it possible for somebody to be in band and in the sports team? Yes. So since it's possible for somebody to be in band and a sports team, that means they're not mutually exclusive. Because mutually exclusive, remember, it means that either one event happened or the other event happened, but it's impossible for both of the events to occur at the same time. So for this one, since it's possible that one student could be in band and in sports team, that's why it's not mutually exclusive. So for this one, how many people do we have in band? Cool. 85. How many people do we have in sports? How many people do we have in band and sports? All right. Everybody go with that so far? Okay. All right. So one thing you have to remember, what does this symbol right here signify? Cool. Perfect. Probability. So that represents probability. So if you look at 85, 85 is not the probability. So what we have to do, we have to find, okay, what's the probability we pick somebody in band in this school? So for this one, how many people do we have in this school? So we have 320. So you divide all of this by 320. Any questions so far while we're dividing by 320? All right. So if you look at the very last sentence, oops. It says, what is the probability a student is involved in either band or sports? So the key word here is or. So we want to find the probability they're in band or sports. Good job. So pretty much for this one, we're going to find a bus. Well, technically not a bus, it's band or sports. So easier to say bus. All right. So for this one, we're going to have to find the probability of B added to the probability of sports, subtracted from the probability of band and sports. So we're going to go ahead and do, remember, if you just label everything correctly, this should be nice and easy. So if you look at the probability of B is 85 out of 320. If you look at the probability of sports is 200 out of 320. Lastly, the probability of band and sports is equal to 60 out of 320. All right. Everybody go with that? So what we're gonna go ahead and do, we're gonna just go ahead and just add that. So we could do 85 divided by 320 plus 200 divided by 320 minus 60 divided by 320. And if you do that mathematics, you get 0.7031, and we'll do 4 decimal places. And that's it for the last problem. Any question for the last problem? All right, so in a minute, what we're gonna go ahead and do, we're gonna go ahead and do this using the Venn diagram. So for the Venn diagram, it's kind of just like, it's kind of like for visual people that kind of want to visually see what's going on. It should help you with that. So if you're kind of like a visual person, it should help you out. If you're not, just use the formula. So it kind of depends on you. So if you're a visual person, you could do the Venn diagram. The Venn diagram will take a little bit longer, but not by that much. But it's worth it as long as you get the correct answer. So let's go ahead and set up this Venn diagram. All right. So let's do the Venn diagram. All right, so here go our Venn diagram. All right, so if you notice right here, I have B and I have this circle, and then I have S, and I have this oval. So if you look at the two of them, which one's bigger, my B or my S? Cool. Why do you think S is bigger? Yeah, cool. Perfect. More students play sports. So that's why it's a little bit bigger. Like you don't necessarily have to do this. If you want, you could just make them both same size. But it kind of help when you're kind of visualizing it. Like you're gonna go, this is a bigger circle because well, it's a bigger circle because it has a higher chance of occurring, or there are more people in this. This one has a lower because essentially there's less people there. Okay, so anytime you're doing a Venn diagram, for the Venn diagram, you always want to put the middle portion. So what I mean by the middle portion, I'm talking about this. So remember, the middle portion are people that fit into both criteria. So people who are in band and in sports. So how many people are in band and sports? 60. All right. Everybody good on where did the 60 come from? Huh. So let's right now, we're going to focus on band. So how many total students do we have that are yes in band? Cool. So we have 85. So we have 85 students that are in band. But let's look at the 85 students that are in band. Of these 85 students, are all of them in band? Oh, sorry. Yeah, all of them are in band. Of these 85 students, are these students that are only participating in band? I'll get to your question right now, Melody. Yeah, let me finish this. Because if you look at the 85, are the 85 people, are they just only in band, or these are some of them also in sports? So if you look at the 85 is pretty much saying we have 85 total people in band, but some of them could also be in sports. So if you look right here, I already have 60 people that are in band and in sports. So if I have 60 people that are in band and sports, how many more people should I put here in order for it to total up to the 85? 25. Perfect. There you go. And I extend the other circle. So whenever you're doing the Venn diagram, what you want to do, you always put the number in the middle, and then whatever number go to the left of it is essentially just kind of like the leftover. So you go like, okay, 60 is in the middle, but in order for me to do 60 plus this other value, you have to go like, how much should I add? And that's the 25. Because if you do 60 plus 25, it's gonna add up to 85. Because what this 25 represents, that 25 represents people who are only in band. So we have 25 people who are only in band, but we have 60 people who are both in band and in sports. All right. Everybody good so far with the 25 and the 60? All right, somebody asked me a little bit earlier on, how do I get the 225? If you do 85 plus the 200 minus 60, that's how you get the 225. I just wanted to give you a fraction form for you. So that's where the 225 divided by 320 comes from. It's doing 85 plus 200 minus 60. Okay, so let's work on sports. So how many total students do we have how many students do we have that do sports? Cool, 200. So if you already look right here, I already have 60 because those 60 are 60 that are in band, but those are 60 that are also in sports. So if I already have 60 in the middle, how many are left over, or how many people do I have that just participate in sports? There we go, 140. Because if I have 60 people that participate in sports and in band, well, that means there's some students who are just in sports. So that will be the 140. Everybody good so far? I got 25, 60, and 140. All right. So if you look at the probability that we want to find, does the Y mean Y or does the Y mean yes? What's your question? Oh, okay. Well, yes, you're good. Sorry about that. Okay. So we have 25. So if you remember, we want to find the probability that they're either in band or in sports. So we only want to focus on students who are in band or sports. So that means all you have to do is add up these three numbers up. If you do 25 plus 60 plus 140, what did that give you? So it should give you 225, which is exactly what we got here, 225 divided by 320. So that's how you could kind of use a Venn diagram. If you could kind of just use the logic and just going like, okay, the middle portion, you can't count the middle portion twice. So once you count it over here, you always have to adjust these two numbers because you can't yet put the 85 and the 200 because that will mean that you're counting it double. So what you have to do is just do 85 minus 60, and that's how you get the 25. And then you do the 200 minus 60, and that's how you get the 140. So that's it for that problem. So you could do it either way. You could either do it with the Venn diagram, or you could do it with the formula of general addition. Both of them will give you the same answer. You kind of depend how you look into these problems. If you're more formula-wise, just use the formula. If you kind of want to logically work it out, you kind of want to use the Venn diagram. Everybody good with that? All right. So up next, we're going to go over the complement rule. So for the complement rule is essentially just mean that we want two events that complement each other. Kind of think about like yin and yang, where they complement each other that make a whole object. So our whole object means it should add up to 100%. So if we have two events and they're complementary of each other, that means if I get the probability of one event and add it to the probability of the other event, it should give me 100%. So if we're looking at this with the Venn diagram, if we have event E, which is this, and we have event F, those two events will be considered complement of each other because once you put them together, they add up to the entire 100%. But say we have this Venn diagram and we have event E, we have event F, but now we have event G. These two events, well, these events will not be complementary to each other because if you look at this, now there are three pieces that we have to put together in order to make it a complete picture. So anytime we have two complementary events, essentially when we put those two events together, it should give us 100%. Or it should give us all possible outcomes. Any question in regard to that so far? All right. And also the symbol for the complement rule is this one. Is a C to, well, is the event to the C power. So if we have A, that means this is the event. If you have A to the C power, that means this is the complement of A. So whatever A is, A to the C power, it's going to complement it. Everybody kind of go with the definition before we start doing some examples to kind of illustrate this? All right, let's do some example. So for, in this one, if you could just type in your response in the chat, that'll be awesome. All right, so for this one, we're gonna do grade in a class. So event E is getting a passing grade in a class. What's the complement of it? So what are the other events that would complement a passing grade in a class? There you go. So put not passing. Cool. Like an easy way to kind of think about it, whatever the event is, all you have to do is put not in front of it and it will give you the correct answer. So let's do this next one. It's weather in Los Angeles today. So event A, it said it will rain in Los Angeles today. What's the complement of that? Yeah, so it'll say it will not rain in LA. There you go. Animate with the not. So it doesn't matter if something else happened, if it's like sunny, a hurricane hit. If anything else happened that's not rain, it's okay because that's the complement of it. So the complement just essentially account for any other outcome that could occur that isn't the original event. Yeah, it's essentially the opposite of it because that's what the not is doing, is essentially getting the opposite of that event. So you can't think about the complement of it, she would be everything else, which is the complete opposite. So if I tell you passing grade, you're gonna tell me not a passing grade. If I tell you it's raining in Los Angeles, you're gonna tell me it's not raining in Los Angeles. So pretty much it's the complement. So I think this is the last one. So this one said a person has a snake for a pet. What will be the complement for that? So we'll say a person, okay, does not cool. So most of your answers are good. The one you do want to be careful because if you look at it, it says a person has a snake for a pet. So when we do the complement of that, The complement of that mean it could be anything else. So it could be the person does not have a pet. But does that mean the person doesn't have a pet if it's a complement? Because right now where you're saying they don't have a snake for a pet. So is it still possible for this person to have a pet? Yes. The only caveat is that this person is not going to have a snake for a pet. But they can have the complement. It's pretty much everything else. It could be they have a rabbit for a pet, they have a fish for a pet, they have a dog for a pet, they have a bird for a pet. So it could be they do have a pet. Yes, that pet is not a snake, but it also can mean that they don't have any pet. So you gotta be careful with that. Everybody good with that? Let's scroll on down. All right. So we're still going to be working with the complement. The only thing is we're going to now add the probability of the complement. So if you kind of remember, I told you that the two events, the probability of A plus the probability of B, should add up to 1. So if you want to write that out as a notation, you could write it like this. So if you do probability of A plus the probability of A complement, it should always equal to 1 because the two are complementary of each other. So if I add those two events, it should always add up to 1. So if you look at this, if I wanted per se to find what is the probability of A to the C power, or what's the probability of the complement of A, what we could do minus probability of A minus probability of A. So now we get probability of the complement of A is equal to 1 minus the probability of A. And that's what this formula is telling us. So if we ever want to find the probability of the complement of A or the complement of any events, all you have to do is find the probability of that event occurring, and you have to do 1 minus that probability, the probability of that event occurring. So that's how we're going to find the probability of the complement. Everybody good with the formula before we go ahead and start doing some examples? All right, let's do some examples. All right, so this one said, let event A represent the event the candidate win an election. Suppose the probability of A is equal to 0.70. So the 0.70 represents that the probability that this candidate win the election is 70%. So part A said, then the complement event of A will be what? So how would I word it? So how would I word the complement of A? So we'll say the candidate no. Cool. Copy that. All right, and that's it. So we'll say the candidate does not win the election. So part B says, what will be the probability of the complement event of A? So we want to find the probability of A to the C power. So for this one, all we have to do is go like, okay, the probability of them winning is 0.70. So the probability of them losing, great job, Evelyn, is 1 minus 0.70, which is 0.30, and we're done. And if you look at that, if I get the probability of A and if I get the probability of the complement of A, they add up to 1 because 0.7 plus 0.30 give me 1 or 100%. Everybody go for the last example. All right, so the next two example, one of them, I'm going to be giving you the probability. One of them, you're going to have to find the probability. Well, if you look at it, you do 1 minus 0.70. So if you do that in your calculator, it should give you 0.30. So if you do 1 minus 0.70, or you could do 1 minus 0.7, it should give you 0.3 or 0.30. All right. So if you look at this next example, it said there are 6 blue ball, there are 7 red ball, there's 3 white ball in a bucket. If you choose a ball at random, what is the probability that it will not be white? All right. So first, let's go ahead and let's find the total balls. Okay, cool. Yeah, that makes more sense. All right, so some of you already went ahead and got this for me. So the total amount of balls in this bucket is 16. All right, so if you look at it, what we want to do, we want to find the probability that it will not be white. But essentially, that's a complement because we want it not to be white. So we want it to be anything other than white. So we could want it to be red or we could want it to be blue. So essentially, that's a complement. So what we could go ahead and do, we could go ahead and find what is the probability that this ball is white. So how many white balls do we have? 3. And remember, you divide that by 16. But remember, this is not what we want to find. We don't want to find the probability that the ball is white. We want to find the probability that the ball is not white. So what we could do, we could just use the complementary rule that says we could get the probability that is white, but we take the complement of that, that we do 1 minus the probability is white, that we do 1 minus 3 out of 16. 1 minus 3 out of 16 is 13 out of 16. And if I use my calculator to calculate that for me, you'll get 0.8125. And that'll be it for that one. Any question for that last example? All right, so let's do this next example. So if you look at this last example, I didn't give you the probability. You had to find the probability in order to do P of W. For the next one, I gave you the probability. So for this one, it says, according to the American Veterinary Medical Association, 31.6% of American households own a dog. What is the probability that a randomly selected household does not own a dog? So remember when we went over the problem about like the event that a person has a snake for a pet, and we pretty much wanted to find the complement of that, which was a person can have a dog, or a person can have not a snake, a person can have a bird or something else as a pet, but they can also have not a pet. So when we're finding the complement of a person owning a dog, essentially we're finding all of these other combinations. So it could be they do have a pet, it's just not a dog. Or it could be that they just don't have any pets. So what's the probability that they own a dog? So what would that probability be that they own a dog? Cool, thank you. 0.316. And remember, if you are having trouble converting percentage into decimal, all you have to do is do the percent divided by 100, and it'll give you 0.316. So if you do have trouble converting percent into decimal, just divide the percent by 100. Do that on your calculator, and it'll give you the right answer 100% of the time, as long as you write down the percent correct. All right, so that's the proportion or probability of people who own a dog. But remember, we don't care about the proportion of people who own a dog. We pretty much care about people who don't own a dog. So what we want to do, you want to find the complement So remember, the complement is essentially, it could be any other pet, or it could be that they own no pets at all. We just care that they don't own a dog. So what we're gonna do, we're gonna do 1 minus 0.316. Cool, thanks, Stephanie. Oops, sorry about that. And you get 0.684. Or if you want, 0. If you only wanted 2 decimal places, 2 decimal places will give you 0.68. All right, but that's it for the last problem. Any question in regard to the last problem? All right, so let's move on to something not tougher, yes, a little bit more thinking involved. All right, so for this one, it said the data to the bottom represent 393,186 travel time to work for resident of Culver City, California. So we have the travel time to the left, we have the frequency to the right. If I look at this data set, is this mutually exclusive? Like if I ask somebody, what was your commute today? Is it possible that they could say my commute was 8 minutes, but also fall under 12 minutes? Like, no, that's not possible. Either you fall between 5 to 9 minutes, 10 to 14 minutes, or 16 to 89 minutes, but it's not possible. So this will be considered mutually exclusive. So you either fall into one of these categories, you can't fall under multiple categories. All right. So let's go ahead and let's look at the first one. So for the first one, it says, what is the probability a randomly selected resident had a travel time of 90 or more minutes? So I'm gonna just write it as this. Probability they last between 90 plus minutes. So how many total residents do I have that their commute time is 90 or more minutes? Oh, 4,895. All right. How many total residents do I have? Good job. So we have 393, 186. So all I'm going to go ahead and do is divide those two numbers up and we get our answer. 4, 8, 9, 5, 11. All right, so I'm going to round this up to 3 decimal places. So we'll get 0.0. Yeah, we'll do 4 decimal places since one of you already gave me the answer to 4 decimal places. All right, and that's it for A. Any question in regard to A? All right, so let's do B. So for B, it's a compute the probability that a randomly selected resident of Culver City will have a commute time less than 90 minutes. So we want it to be now less than 90 minutes. So I'm gonna go ahead and label this. So I'm gonna say this is A, this is B, this is C, D, E, F, G, H, I, J, K, L. So if I want to find the probability that somebody have a commute time less than 90 minutes, which of these columns should I use? Should I use all of them, some of them, or one of them? Like, which column should I use? Oh, A through K. Very cool. So we got A through K. Perfect. So if I want to find the probability for this one, what I could do, I could add up all the frequency for all of the frequency for A all the way through K. But the thing is, this case scenario, there's an easier way to do this, and this is where you want to use the complement rule. Because essentially, for this one, we have two complementary ideas. Because we have people who have a commute time that are less than 90 minutes, but the complement of that, what will be the complement of that? Cool. So yeah, so essentially the complement of less than 90 minutes are people who have commute time that is 90 or more minutes. So instead of adding up all of these, what I could just go ahead and do, I could, oops, sorry about that. Let me change that. So if I want it to be less than 90 minutes, what I could do, I could take the complement of what I found in part A. Because I could do 1 minus this probability, which is 4,895 out of 393,186. And then we could either do 1 minus 0.0124. And then we could do, oops, 1 minus 0.0124. And you get 0.9876. You might want to check, Stephanie. I think you forgot to put the 0. Yeah, that's fine. This is where you could do your mistakes. Okay. So you can kind of see how important the complement rule is, because the complement rule, it kind of meant for like a little shortcut. So if I know the probability of this one event and I want to find the complement of this event, well, it's either you have to take the complement versus finding, well, versus going all the way from A through K, adding that up and then doing 1 minus that. It's much easier to get the last row, which is L, and you do 1 minus 4,895 divided by the 393,186. All right, but that's it for B. Any question for B? Now, in the test, it doesn't matter how you do it. Like either way, you should still get the same answer. It is going to be one way going to be a little bit shorter. One way is going to be a little bit longer. But for the test, like it really doesn't matter. Both of them will give you the same answer. All right. So up next, we're going to go ahead and try this. So if you look at it, it's exactly the same problem. So we have probability of it being comedy is still 0.20. Probability is produced by Warner Brother is still 0.09. Probability is from both C and W is 0.02. So if you look at part A, it says, what is the probability that a movie coming out of Hollywood is not comedy? So we want it to be not comedy. Oops, sorry about that. So if I want it to be not comedy, which of the complement are we taking? Are we taking the complement of C or the complement of W? Cool, C. All right. So we'll do C to the C power. So that look a little bit weird. So for this one, we'll do 1 minus the probability is a comedy. So we'll do 1 minus 0.20. 1 minus 0.20 is 0.80. And that's it. So if I know 20% of movies produced in Hollywood are comedy, well, that means that 80% of the movies produced in Hollywood are not comedy. So that means we could have romance, we could have action movies, we could have, what other movies? Fantasy movies, we could have, well, I'm out of it. But yeah, 80% of the other movies are something other than comedy. So let's do B. What is the probability that a movie coming out of Hollywood is not produced by Warner Brothers? So for this one, we want to do probability W to the C, because we want to find the complement of Warner Brothers. So for this one, we're going to do 1 minus, and what percentage should I put on the right-hand side? What should I subtract it by? Yeah. 0.09. They get 0.91. Yeah. And that's it for B. Any question for B? All right. All right, so we're all done with that section. So one thing you kind of want you to notice, because in this section we're going to do a slight difference. So in the last section, it was always that we're randomly selecting one object or we're randomly selecting one person. So in 5.3, that's going to change because instead of randomly selecting one person or one object, what we're going to do, we're going to be randomly selecting multiple people, so, or multiple objects. So instead of us just randomly selecting like one person, it's going to be we randomly selected 2-person or 3-person or such and such. So I do kind of want you to get into the mindset of like saying the last section was when we're doing multiple selection. This section is when we're only doing once, or we're doing multiple selections. So the last one, we're doing single selection. For 5.3, we're going to be doing multiple selection. All right. So up next, we're going to get into something called independent events, and we're going to get into dependent events. So when we're dealing with independent event means that one event, it shouldn't influence the probability of the next event occurring. So if I tell you the probability, if we have 2 events, one of the events is it's gonna rain, and the other event is you got an A on your stats test. Those 2 events are independent from each other because the fact that it's rainy, it shouldn't affect your grade in a statistic course. But say one of the event is it's rainy and the other event is you brought an umbrella to work, or you brought an umbrella, well, pretty much just to work. So those 2 events will be considered dependent because one event does influence the other event, because the event that is rainy, it should pretty much influence that you're going to bring an umbrella. If it's not rainy, you're more likely not to bring an umbrella. So when we talk about independent event or dependent event, we're kind of referring to that, where you're saying one event shouldn't influence the other event, and that's independent. But if one event influenced the other event to occur, that's when we say there's a dependent event. All right. Everybody good so far with that logic before we move on? Cool. All right, well, we'll do some example right now, so that way we'll kind of hammer that in. All right. So for this first example, we have John roll a 6 on a number cube. So we'll say that's event A. So we'll say event A. Event B, flip a coin that come up heads. So event B, what do you say? Heads. So if I roll a 6 on a die, does that affect the probability of me getting heads on a coin? No, since one event doesn't affect the other one, this will be considered which one, independent or dependent? All right, and we're done. All right. So let's go ahead and do the second one. So the second one said your teacher chooses one student to lead a group and then chooses another student to lead another group. So All right, so we have student A. So the teacher gonna choose student A to lead group 1, and then student B is gonna lead group 2. So so the way that I choose the first student, does that affect how I choose the second student in this class? All right, so we have yes or no. Well, let's kind of think about it. Say if I have, let's say we have 30 students in a class. So when I pick the first student, what's the probability that I picked student A? Cool, 1 out of 30, perfect. So there's a 1 in 30 chance that I choose student A to lead group 1. What about for student B? When I choose student B, what's the probability that I choose student B given I already picked student A to lead group number 1? Perfect. It should be 1 out of 29. So if you kind of notice, the probability slightly changed. Because once I chose the first person to lead the first group, now there's one less student for me to choose from. So since there's one less student for me to choose from, pretty much now it's going to change the probability. Since it's changed the probability, this is dependent. Because this event B is dependent on what happened on event A. So that's dependent. Everybody good on this second problem? All right, let's do the third problem. The third problem is a little bit trickier, could kind of depending on some situation. So for this one, it said the battery in your cell phone is dead and the battery in your calculator are dead. So I'm going to say event A, we'll say cell phone. We'll put cell phone is dead. We'll put calculator. All right. So we have the event. So cell phone is dead. B, event B is calculator dead. Does the fact that your cell phone is dead, does that affect the fact that your calculator is dead? So since it doesn't, what should I put for the event? Is it independent or the dependent? So for this scenario, can it ever be dependent? Well, when can it be dependent? And kind of think about this class for this semester.
If the calculator's on your phone.
There you go, perfect. So yeah, so it could be dependent because if your cell phone is your calculator, then if your calculator there, well, your cell phone is also there because they're the same thing. All right, good. All right, so let's do this next one. So for this one, say your favorite color is blue and your favorite, oh, not your favorite, your friend's favorite hobby is fishing. So we'll say favorite color is blue. All right, so for this one, we have event A, which is your favorite color is blue, and event B, which is your friend's favorite hobby is fishing. So for this one, the fact that your favorite color is blue has any influence on the fact that your friend's favorite hobby is fishing? Cool, long no. All right, so since the answer is no, what should I say? Is it independent or dependent? So for this one, we should say is independent. All right, so you do kind of want to work on this. Also, you might want to work on, because some students, for some reason, they always confuse independent with mutually exclusive. So like just write on notes and you kind of describe why are independent, dependent different. So that way you could kind of understand it. Because like one thing I was noticing for the test, some of you like knew the definition for the Chebyshev rule or for the empirical rule, but when it came time to use those definitions to kind of tell which of those two to use, you pretty much started using like because of the standard deviation or because of the mean was given, which had nothing to do with it. So make definition for them. You kind of say like what's the difference between independent and dependent. So that way for test and quiz you won't get confused. All right. Everybody good with that so far? All right, so that's independent, that's dependent. So hopefully that's not that bad. Okay, so in the last section, we went over the general addition rule. So in this section, we're gonna go over the multiplication rule. So the multiplication rule is when we have multiple selection. So we want to use the multiplication rule when we have multiple selections. So this is going to be a little bit different because if you remember, what did this symbol signify? Cool, and perfect, thank you. So that symbol right there signifying and. So before it used to signify that one person, one object have to have both criteria. But now, since this is for multiple selection, what it means find the probability that the first person or the first object have this criteria, and then that the second person or the second object has this second criteria. So in order to find that, we're going to do probability of A, and we're going to multiply that by probability of B. So I'm going to show you why this formula kind of works. And what I'm going to have to do, I'm going to have to do this on some scratch work. There we go. So let's do flipping a coin. Not con. All right. So when we did flipping a coin, if you remember, we actually came up with the sample space. What's the sample space for flipping a coin 2 times? Cool. So we have heads, heads. We have heads, tail. We have tails, heads. And lastly, we have tail, tail. Everybody good with that idea? All right. In this sample space, how many outcomes do I have? So we say, oops, 4 outcomes. So in this sample space, we have 4 outcomes. So say for this one, if you look at it, we did multiple selection because essentially we're saying we're flipping this coin twice. So say we want to find this. We want to find the probability the first time we flip the coin. So I'm going to just be very explicit here. So we'll say first time we flip a coin, we get heads. So when we first flip the coin, we flip the coin and we get heads. So that's what I want to happen in the first try. So when I first flip the coin, I want it to be heads. So then what I want to do, now I want to put the and, because now the second part is going to be what happened in the second selection, in the second flip. So then we're going to say in the second time we flip So what we want the first time we flip a coin, we get head. The second time we flip a coin, it lands on tail. So kind of going back to the last section, if I were to tell you, find the probability that it will be head and tail, for that one, you would tell me the chances of that happening is 0% because the chances that will land on head and tail in one single flip, that's 0%. But what's happening here is instead of saying we're doing one single flip, now we're saying that we're doing two flips. So that's what makes this a little bit trickier because you have to just understand that instead of doing one selection, now we're doing two selections. So now it's okay to say probably the first one is head and the second one is tail. So essentially what we just want to find this. So how many of those four outcomes give me where the first flip was head and the second flip was tail? Yeah, so 1 out of the 4. Cool. Everybody get how we got 1 out of 4? Okay, so now I'm going to bring it around on how does the formula work. Because if you looked at the formula was saying probability of A and B is equal to the probability of A times the probability of B. So let's try to use this formula for the problem that we just solved right now. So we want to find the probability it land on heads and then it land on tails. So if you look right here, it says probability of A. So that means we have to find the probability of H. And then if you look at here, now we want the probability of tail, because that's what B is. So we say probability of T. Any question on so far why we have probability of H times probability of tail? All right, and for this one, it's important that these two events are independent from each other because you can only use this formula for independent events. Because for this one, if you kind of think about it, these two events are independent from each other because it doesn't matter if the first time you flip the coin is head, the time when you flip the coin the second time, the probability that that coin land on the head is still gonna be 50%. So that's why they're independent events because it doesn't really matter which happened the first flip or the second flip, like each event are independent from each other. So for this one, what should I put for the probability that it land on heads? If I'm doing it like a single flip, 0.5, I'm gonna do the fraction, I'm gonna do 1/2. What's the probability that the coin will land on tail? Cool. 1/2. So if I do 1 times 1, you get 1. If I do 2 times 2, you get 4, which is this answer that I got over here. So that's how we're using the multiplication rule. Is essentially it's a shortcut way of how to do it. Instead of you listing out all of the outcome and then you see how many outcome and then dividing by those outcomes based off of the event outcome, all you have to do is get each individual probability and you just multiply them times each other. And this should work for all events that are independent from each other. Everybody good with the formula? Great. All right. So let me go back to the notes. All right. So we're gonna stop right there. So remember, today's Wednesday. So anything that we went over today could be on the quiz, which is gonna be tomorrow. So let me show you where to find the quiz. And like always, I'll email you somewhere like around 3 o'clock to let you know if you still haven't taken the quiz. For that, you don't have to reply back to me. I'm just letting you know that you haven't taken the quiz. So whenever you can, try to take the quiz as soon as possible. But just remember, you have until 7 p.m. to do the quiz. So don't feel obligated to email me back. I'm just sending you a friendly reminder to take the quiz before 7 p.m. All right. So for quiz number 4 will be right here in week 3. So June 29th to July 5th. Just go right here, take the quiz. Like always, it's going to be open all the way from 7 a.m. to 7 p.m. So anytime tomorrow from 7 a.m. to 7 p.m., you do want to take the quiz anytime from there. Any hint for the quiz? Well, it's going to have something to do with probability, which isn't that good of a hint. But you can do 6 question. I think it should have, yeah, it should have 6 questions. Here, I'll double check that for you now. No uploads. Yeah, it should have 6 questions. Here, let me update that. Okay, so just remember you're gonna have, oops. So you have anywhere from tomorrow to be able to do the quiz. And I think how much time here? I'll give you 20 minutes. Like it shouldn't take you that long. As long as you just know what you're doing, it should be fine. And for tomorrow, there's not going to be any upload. So it really shouldn't take you that long to do the quiz. I'll give you 20 minutes to do tomorrow quiz. And also just pay attention to rounding, and pretty much for all of the questions, I want them all in decimal form. So do please put them in decimal form for the quiz. Yeah, 9 through 16. Yeah, that's correct. Also, one last thing here. Let me stop share. One last thing for the for exam, if you do have an emergency, put on the subject line emergency, because for the last exam there's some emergency that happened that I kind of ignored because I thought you were just uploading questions and stuff like that, because I had like 50 email during Monday. So I just thought you were just emailing me your upload. So if you do have an emergency, that something come up that you need to get the exam pushed back, put on the subject emergency, so that way I know it is an emergency, and that way I could look at that email or prioritize that email, because if not, they all get lost in the shuffle of the many emails I get. So if any time during a test or during a quiz, if an emergency happens, email me as soon as possible, and make sure on the subject line you put emergency, so that way I know it is an actual emergency, so that way I can look at the email. Because if not, they might get buried throughout the other emails I got. All right, but that's it for today's class. Any question before I close out this meeting? All right, cool. All right, so just remember tomorrow you have a quiz, and tomorrow you have lecture at 7:30. And remember, if you do have any question in regard to the test correction, do ask me during office hour, because like I said, for the test correction, I do grade them harshly. So if you have any question, ask away, because if not, I'm going to assume everybody just know what I expect. But if you do have any question about anything, just go to the office hour and I'll clear it up for you. All right, guys, so that's it for tonight. I'll see everybody Thursday, and do the quiz.